So I want to talk a little bit about remote control hydraulics, pilot controls, and electrohydraulic controls, and what we might encounter on heavy equipment. So what I've got here is a 3-spool directional control valve. Not sure of its application, but it is an open center control valve. Here's the port for oil coming in, coming through, out. Under these plugs are our load check valves. We've got 6 work ports, for 3 functions. A pretty typical valve, something similar to what we looked at earlier on our lift, tilt, and auxiliary valve on a Bobcat machine. But this is in some ways way simpler. I don't see any electrohydraulic controls on it. The 3 spools, one of them has a location for linkage, so this one would have been mechanically operated, whatever the function would have been. There would have been linkage here, or a cable at least. And the operator's hand would be mechanically moving this spool. These two, the first and second, as oil progresses through the valve, are pilot operated. So these don't have any linkage. They've got fittings where small hoses could connect to maybe a valve like this. We'd have to have 2 of these to operate those 2 functions, but we've got a smaller directional control valve, a pilot control valve with a handle on it that's operating some smaller plungers. This one's not super visible, but you can see down in there there's a plunger that's going to get pushed down when I go this way with the handle, and down here there's a plunger that's going to get pushed down, and that's going to move a couple of small valves in here. And at the bottom here there's going to be ports where each of those plungers or spool valves is going to have a line that would connect to one end. So one hose would connect to this end of a DCV spool, the other port would connect to this hose, and then the back and forth action of that valve can operate this valve hydraulically. So why not just use linkage? Well, the benefit here is now this valve doesn't have to be anywhere near the cab. You can have the operator up in the cab with this smaller valve, and then wherever hoses can run, whether it's 10 feet away or 50 feet away or a foot away or 200 feet away, we can have this valve. So we're now remote from the valve. The valve doesn't have to be in or near the cab. We don't have to move high pressure, hot oil in and out of the cab area where the operator is. And all the noise and heat that's associated with hydraulics, it can be moved away from the cab. We're still going to need some hoses coming into the cab, at least 2 that could connect here to that one spool, and then this next valve is going to need another valve like this to operate it. And you might get in some wheel loaders and find 2 of these mounted next to each other, one for lift and one for tilt. Fairly common to have single axis controls like this. Maybe a little more common now is to have a joystick, which is really the same technology as this, but now we got 2 axes built into one valve and a wobble plate in there. Instead of 2 plungers, now there's 4 plungers operating the valves. And when you take the boot off, they look something like this. So now on this axis of movement, let's call this the x-axis. I move this way. I can move these 2 plungers. So the hose is connecting to these 2 ports, can run out to one of the valves. We can have x-axis of hand movement operating that. I lost where I was on which plungers, but then the other 2 plungers, they can connect with their hoses across to a second spool. So we can effectively operate 2 control valves now with one hand and with this kind of arrangement. So now if I look at this Volvo tractor loader backhoe, we've got 2 joystick handles, and those small pilot lines run down to the directional control valve that's underneath here. And then we basically have this set up on the back of that machine. This is from the BL70 manual, so we have our 2 joystick valves. Those 4 hoses, 2 down this side operating 4 down this side operating 2 different spool valves. 4 hoses come down here to control these 2 spool valves, and these 4 valve sections would be for our backhoe, for our stick, boom, bucket, and swing functions. The only other hoses that need to run up here are supply to take some pressure up to operate and send back to the valve. So there would be a pilot supply line running up, and then a line connecting to tank. So there would be 6 hoses running up here, 6 hoses up here, 4 of them for control of the valves, each end of 2 spools, 4 of them for each end of 2 spools here, and then of course supply and return. So in hydraulics we don't really have hard and fast definitions of high pressure, medium pressure, low pressure like you might have in electrical systems, where the Canadian Electrical Code defines what different voltages are. But here when I'm talking medium pressure, typically in a modern machine we'll see a pilot supply pressure to a valve like this in the neighborhood of 500 psi, and plus or minus 100 or 200 one way or the other. Some machines work at lower pressure, some work at higher, but generally we're only feeding about 500 psi of pressure up into the cab, where this valve then could be controlling to a hydraulic cylinder, thousands of psi of pressure. So a medium pressure system now working to actuate the spools back and forth, and that's controlling the high pressure system where the oil's coming in from the pump. And of course the pressure is going to be dictated by the load induced pressure. And again, this is not to be confused with load sensing or anything. I'm starting intentionally here with a system that just uses open center hydraulics. It may very well use a gear pump or a vane pump. So we can have this type of system actuating a valve that's very basic with open center and fixed displacement pumps, or we can have these types of valves, operating valves, that directional control valves that do operate in a load sensing environment. But it's independent reasoning in the engineering here. So this is really to get high pressure out of the cab and get the operator maybe away from the control valve. So a wheel loader is a machine that's really almost always going to have pilot operator controls in the cab, because the main directional control valve on the machine, see if you can see it, is up there over top of the front axle on the front frame. So your main hydraulic control valve is up front, operating your lift and tilt cylinders on the front of the machine. So obviously when the machine articulates and it's steering in the middle, we can't have linkage connecting the cab that's on the back of the frame to the hydraulic control valve on the front. So what we're going to have instead is a bundle of small hoses running up to that directional control valve up over the axle, which is a pilot operated directional control valve. So in the cab of this machine we have a 2-axis joystick control for lift and tilt of the bucket, and then we have a single-axis joystick pilot control for our auxiliary. So here's a test. How many hoses in total must be coming up into this console here to operate those functions? I'll let you mull that over. So we'll have to take a look at these pilot control valves in a little more detail. These are closed center directional control valves. So these small medium pressure valves in the cab are closed center, and they may be feeding an open center or a closed center directional control valve that's going to handle main system flow to the implements, but these are always going to be closed center. So when we look at these 2-axis valves, we're going to have a total of 6 ports on the bottom. We're going to have 4 ports that are going to have hoses leaving to go and control 2 spools. And then we're going to have a supply port that often is labeled P for pressure supply. And again, that's going to be regulated to typically 500 psi. We've got some machines that are 300, some that are 600, but in that range. And then we've got a connection back to tank. So closed center. So when the pump is feeding to P, if we're not using any of the functions, if we've got our hand off the control handle, then that supply is blocked, as you'd expect with a closed center valve. So the supply to this valve has to be regulated to the pilot pressure of 500 or whatever the spec is for the system, and then a connection back to tank. Now the lines that go down to the 2 functions that are going to be operated by this valve, I don't know if we want to think of those as work ports, but they're kind of like the work ports of this valve. They're different again from, in this case, the main control valve, because the work ports here that go down to the caps, when you take your hand off the control, are connected to tank. So if I were to blow air through any of these 4 ports, the control lines, right now in the hold position with my hand off the controls, they would all blow through the tank. If I tried to push air into port P, the supply, it would just be blocked. So let's try that out here. So I'm going to try and push air pressure into one of the work ports. Just blowing out tank. And this one. So all those ports right now are connected to tank. That's important. So when the operator takes their hand off the control, the centering springs, whether there's one or two in the valve DCV section, those centering springs or centering spring can drain or can push the spool back to the hold position, and whatever oil might be in these fittings is going to be able to drain back to tank through the control and the cab. So for the centering spring to be able to do its job and center that valve, we can't be trapping oil pressure here when the operator lets their hand off the control, or even trapping static pressure. So there's got to be a connection back to tank. So that's why all those ports for the functions, again, I'm hesitant to call them work ports, but they kind of are. That's why they're all connected to tank in the hold position. Again, P port, supply port, I said. Seal because our air pressure is pretty high here, but basically doesn't go anywhere. Oil tries to go in there and it's blocked. So again, closed center valve, there's no connection P to T, but all the work ports or function ports are connected to tank in the hold position. So then if I supply the valve and I activate it, start to send P supply oil to whichever port I push the plunger down for. So as I push the plunger down, you might think I'm directly opening a valve that sends the oil out, but there's springs and a metering section in here. This is a little more sophisticated valve for modulating the oil pressure. So we'll come back and take one of those apart and have a look at what's inside. I want to move on to a little different technology. You might have a joystick handle in the cab and a remote mounted control valve like we have on this D3K Series 2 machine. Here's the directional control valve. If we went out to an older D3, like a D3G, we would find that the control valve is sort of in a similar location and the operator's hand's right there. There's not much distance, so there would just be mechanical linkage going between the operator and the control valve. Not much distance. This machine is not pilot operated, but there's no linkage. This one is solenoid operated. So we've got electrohydraulic controls here, and technically the valve is pilot operated, but it has its own internal pilot system. So that joystick up in the cab now is not a pilot hydraulic control. It is some electronic joystick that looks probably very similar to this. And it isn't dealing with oil at all. It's only dealing with electricity, and it's sending electrical signals to an ECM that has the control for the hydraulic valve in it. And the inputs go to the computer or the ECM. The outputs from the computer go to solenoids, proportional solenoids at the control valve. So this is a very similar control valve to that one we were just looking at. So we've got a valve very similar to this, except it's not pilot operated and manually operated like this one. It's basically this type of valve that's been electrified. So on this system, supply from the hydraulic pump comes in this pipe at the back and feeds into the valve back here and comes through the valve. It's an open center valve again. So lots of control technology, but it's still just open center hydraulics. And then out the return line, we're going to go back to a filter and then ultimately to the tank. Got a main relief over here, not load sensing or anything fancy like that. It's just open center with a main relief, but the control is electronic. The pump itself, just a gear pump mounted on the front of the engine here. So that's our hydraulic pump that's feeding the implements. And of course, we got three functions. We got 6-way blades, so we've got lift, angle, and tilt of the blade. So this is a pretty simple hydraulic pump with a 6-way blade on a small dozer and or a hydraulic system with a 6-way blade and just a gear pump and an open center valve. And you might be wondering why electronics on a machine that's basically so primitive. Here's our electronic joystick. So again, there's no pilot lines coming up here. And what I will notice, they could have done this with pilot, but compared to the G series tractor that we've got in our fleet as well, the hydraulic control is mounted on the console here, so the linkage can go down to the valve. Well, this one, the control is mounted to the seat, and it's a suspension seat. So we've got a wiring harness that can flex as the seat goes up and down. That's minor. That's not the main reason why we've gone to electronic controls on a dozer. The main reason for having electronic controls on a dozer is so that the machine's ready for grade controls, whether it's one of 2 or 3 different systems that can be applied to this machine, where the operator just becomes the driver of the machine and software goes into a module, and then that module, based on GPS and civil engineering's information, can control the blade electronically. So, or just line of sight, electronic grade sensing. So that's why virtually all dozers have gone to electrohydraulic control of the implements. A couple other neat features. They're able now to move the some of the controls to something like a thumb wheel, and we've got a blade shake function that can oscillate the controls and kind of shake the material from the blade. Some bells and whistles. But the main reason, this machine's not equipped with grade controls, but it's ready. It's basically plug and play. You can put grade controls on this machine and then let the grade control system take over the hydraulics. So as a technician, as we add more types of control to a directional control valve, whether it be pilot hydraulics or whether it be electrohydraulic implement controls, now as a technician, we're always having it to, in diagnostics, we're always trying to have to draw a line in the system between controls and main system. So if that blade won't lift, now I have to apply my knowledge of fundamental hydraulics. Is that gear pump providing flow? Is the system pressure what it should be? Is the cylinder bypassing internally? All those fundamentals of a hydraulic system have to be applied in diagnostics. And then we have to maybe diagnose the electronic system as well. So the point we're going to start that diagnosis is where the electronics and the hydraulics meet, which is going to be at the directional control valve. We may want to know as a technician, are electrical signals being sent to these connectors on the valves to proportional pressure in there? And then with this valve, we're saying it's not pilot controlled, but it actually is pilot controlled. There is a pilot pressure generated within the valve itself. It's got its own pressure reducing valve, and it makes a pilot pressure because electricity itself can't propel these spool valves back and forth. These would have to be giant electromagnets to do that. These are very small proportional solenoids, and they direct medium pressure again to the caps on the ends of the spools. So these valves are directing oil into the caps on the ends of the actual DCV spools to move them. So now we've got electrohydraulic controls. And similarly, if we back up sort of one level of technology and go to hydraulic pilot, hydraulic remote controls, again, we've got 2 systems to troubleshoot. The main implement system, the main hydraulic system, the pump, the control valves, the relief, the cylinders, lines, all that stuff. And then we've got to think about the pilot system. Do we have supply pressure to the pilot control valves? Where is that coming from? Do we have the pressure going to the spools? If we've got a valve like this, again, immediately my troubleshooting hat kind of comes on, and I see this spool that's manually operated. I think that's a great troubleshooting point with this valve. If I ever get a system where these functions aren't working, I'm going to try this function. If this function works hydraulically and these functions don't, well, I'm pretty sure I've got a problem with my pilot control system. If none of these three functions work, this mechanically operated valve and the pilot, well, then I've got a problem with the main hydraulic system. Maybe I've got a pump issue, or maybe the main relief, or something with the supply. So not to introduce troubleshooting at this point in the course, but well, it's all troubleshooting, because the first step of troubleshooting is to know the system and know what you're dealing with and know how it works. And then when something isn't working, if you know what component's supposed to do that job, you've kind of got it troubleshot before you've even begun.